Welcome back to Industrial Automation course, Lecture 15, Programming Timers and Counters in TIA Portal. Today's topics are as follows. Programming TOM block in TIA, programming TOF block in TIA, programming RTO block in TIA, programming TP block in TIA, programming counter up block in TIA, programming counter down block in TIA, and programming counter up and down block in TIA. Okay, so we are in a point of a semester that you should choose to start picking a project for your final project, because we don't have any final exam and it's a project base. Okay, so start thinking about the course project right now. You have to determine the topic of the project by Friday 30th of October, and you can have 3 students in one group. So you could collaborate online. There is no any issues on this one, and you could submit all together. But if you're choosing to be 3 students, then the size of the project also should be uh, reflected into that. So 2 students, they could pick a smaller project. 3 students, they should pick a little bit bigger project. Prepare a short proposal of the course project and submit it through the Moodle. Determining the group members, we will check the proposal and provide you the feedback if necessary. The project should be done using the codices or TIA based on simulation. So it's up to you to choose which type of environment you wish to choose. If you are looking to program it with codices or TIA, it's up to you. Or you could do the same project with both and you will get a bonus. Okay, so timers in TIA portal will start with on timers in TIA or TON. Create a project in TIA at the S71212C ACDC relay as the processor and open the programming environment. Refer to previous lectures for getting help. So throughout the whole video, whole lecture, we will use this specific hardware just because we had access to this hardware in the lab and is one of the simplest hardware that you could pick and choose. So do the configuration based on this hardware, but later when you want to download the program, download it to a simulation. So refer to the separate video how to use TIA simulation, and instead of downloading to the real hardware, you will download it to simulation. Now double click on block main. Okay, so main or organization block 1 here, I'm going to show here with the laser point. And you see that now we don't have any program, it's empty. So do the configuration based on the previous lecture and then continue programming on this video. Okay, so follow the slides and see how you could add a timer and counter. Okay, so now insert a contact, rename it as start, and define the corresponding tag. Okay, so you choose the name start and right click on that and define a tag. Okay, so step 1 and 2. Accept the default setting and define the tag. Okay, so you could define and accept the default setting. The issue is that if you choose a default, it starts with M, it means that this is an internal memory, but we're gonna associate start with a real input, okay? So you could either choose I0.0 here, or in coming slides, you will see how you could associate one input and output to one specific contact and coil. Okay, so you see the steps 1, 2, and 3. Insert a TOM block or on-timer block into the program using drag and drop. You can find it in basic instructions, timer operations. Okay, so we have a on-timer delay here. Under timer operations, you could select this and drag and drop it into the programming environment. As soon as you place the timer in the program, you will see the call option window. Okay, so now you drop it here after the start. Now you will see a call option window, and you could choose a name for your timer. Leave it as automatic and click OK. After you click OK, then you have one instance of a timer as the name you chose. Now you should select a preset time value, and here click on the preset time value and write 4 second. So it should be T sharp 4 second. So the formatting should be exactly as you could see here. Insert another contact and associate it with the down bit of the timer by double clicking on the name of the timer and selecting Q from the list. So this is a second wrong. This is the second wrong. You need to associate it with the down bit of the timer. The down bit of the timer is Q. So you will select the name of the timer and then Q. How you could do that from the drop down menu when you click here. Okay, so 1 and 2 is selecting the name. The name of the consider variable will appear on top of the contact. Okay, so now you have the name here, name of the timer .q. Insert a coil and define a tag named output accepting the default value. This is a coil. Okay, select the name. You could leave it as a default value here and then click define. Okay, now you are adding one coil to the second rung. Okay, so you could either choose a proper address while you are defining input and outputs, like a start and output contacts and coil, or you could follow these steps here to associate the proper input and outputs to your contacts and coils. Now we have to associate the inputs and outputs that we have in the program with the real input and outputs of the PLC. To do so, split the window first to see both the program and the PLC at the same time. Okay, so split the window with this icon here, so you could see on the right side, you will see the PLC, okay, on the hardware configuration, and on the left side, you will see the programming environment. Both the program window and the PLC in the device view should be displayed as below. Then you have to click on a specific input of the PLC, drag it and drop it on the start contact. Drag DO 0.0 and drop it on the output coil. So you will select one of the inputs, drag and drop it to the proper contact, which is the start, and the output, and drag and drop it to the proper output, which is the coil. We name it output. Okay. So here you could see better on this slide. Now the start contact is associated with the DI 0.0 and the output coil is associated with DO 0.0. So you see here that, for example, this is one of the output. Drag and drop it to the proper output. You could use this method, or you could just simply select a proper address. So instead of going with the default M0.0, you could just go and write I0.0 and name it with a proper name. Yes, so instead of selecting and drag and dropping here, this is a very good method for a large number of inputs and outputs for complex PLCs and complex hardwares. But for this simple case, maybe it's better to go with writing a proper input and output address when we are defining our contacts and coils. So you see, for example, for input 1, for output 2. TON in TIA. Now we have to connect the PLC and load the program to it. Start by detecting the available device. In the online access, Intel R network connections, double click on update access devices. Okay, so this one. This name might change depend on your PC or laptop. Okay. But what you should do, you should open it and then click on update access to devices, and then you will see the list of available devices on the network that your PC is connected. And in this case, because you only have one PC, you will see one PC. The reason I'm going through these steps, I know you don't have access to the device, but later in the next semester, hopefully after this COVID-19, you will have the chance to touch the real device, go to the lab, connect your hardware. So I'm going to go through the steps because anyway, it's part of your learning program and you should know what are the steps, how you could see the real device, and so on and so forth. But you don't have to follow these steps if you are using a simulation. Okay, so you could skip this part. Selecting a device. Okay, so you will see the device, select the device, double click on the online and diagnostics to see the details regarding the device. Okay, so this is the device and this is online and diagnostic tab. The MAC address of the device, which is a part of the Ethernet address, can be used to identify it in the network. Okay, so the MAC address is this one. Under the diagnose and function, you see the MAC address. You can find the MAC address of the PLC written in its front panel. Okay, so here is the front panel and you could see the MAC address. Or any other Siemens PLC, you could see the MAC address written somewhere on the hardware. Okay. Again, if you are using a simulation, you could just skip it. Now you have to load the software and the hardware configuration to the PLC. Right click on the name of the PLC, select download to device, and then all. Okay, so here you could just right click download to device all, instead of downloading to the real hardware, if you have turned on your PLC simulation, you will download to the simulation. Okay, but anyway, if you are using simulation, you have to download it, but the simulation should be on. Okay, TIA simulation. Again, review the video I uploaded on Moodle. I provided the link on Moodle to see how you could use TIA simulation. In the extended download to device window, specify the type of the PGPC interface as PNIE. Wait for the accessible device to appear in the list here. Okay, so you see the MAC address also. Find your device by checking the MAC address, selecting it, and click on load. So for the simulation, you will choose a simulation and then click load. Okay, 1, 2 steps, and finally load. Click on load. In order to load the program, select starting all and click on finish. So when you click starting all, the program will start simultaneously after you click finish, or the PLC, I could say, will start scanning and going through the cycle. Otherwise, you have to run the PLC by yourself. And it doesn't matter if you're in simulation or your real hardware, you have to run the PLC manually if you don't select start all and finish. So start all and finish. PLC will start to run the program continuously. Okay, so these stages are also the same for the simulation. If you go online, okay, so you need to click on this one, go online. Okay, here. You can change the operation mode of the PLC. Okay, here on 2. Okay, so this is online and this is operation. This is where I mean you could stop and start your PLC manually. Okay. Turn monitoring on off. This is by this icon. So once you do so, you will see these color codes of green and blue. Green means that the logic is true, and the blue means that the logic is false or gray. So in which you can see the values of the variable in the program online. Note that the true logic is displayed by green color and false logic with blue color in the program. Change the input to the PLC and check out the operation of the program and the change in the state of the output. So if you are using a real hardware, you have to change the status of the input and in the lab by switching. So you could switch from off to on. If you are using simulation, right click on your contact and then modify from 0 to 1. Okay, so once you modify from 0 to 1, it means that now the contact is on and you will see that the timer will start timing. Insert a TOF block in the program, associate its input with the start and its output with DQ 0.1 or output. Download the program to the PLC and check the function of the TOF. So very same steps, but instead of using TON, you will use TOF. And I'm gonna leave this part to you to check the functionality of TOF instead of TONs. TP in TIA, insert a TP or pulse timer block. Okay, so this is an off timer, and this is a pulse timer, associate its input with the start and its output with the output, download the program to the PLC and check the functionality of the DP, okay? And retentive timers, insert a retentive timer block in the program, associate its input with the input and output with the output, and download the program to the PLC and check. So if you remember, codices doesn't have retentive timer. You had to write your own function block, but TIA has a retentive timer as one of its default timers, and you could easily pick from the timer operation list and use it. Insert a counter op block in the program, associate its input with the start and its output with the output, set the preset value to 5 here, and connect the reset input of the counter to DI 0.1. So you see that you have to associate the reset to another input. This is another real input. Download the program to the PLC and check the function of the counter op by changing the status of the input. Again, you could easily program the TIA in the simulation mode and check your counter op and right click on these counters and modify them from 0 to 1 and 1 to 0. Go online, monitor the program and check the functionality of your program. So this is where you could select the counter op. This is where you could basically drop it here, sorry. Here is the output and this is the preset value. And this is the reset contact. Insert the content down block, follow the same steps, very similar. I'm gonna leave this part also to you, and pick a preset time value and check your program and see the functionality of the program. Counter up down block, very similar. Again, you could drag and drop it from the counter operation list here in the basic instructions. You have to associate one contact to counter up, one to the counter down, one to the reset, and you need to select a preset value. And you also have LD. Check the functionality of the program again in the simulation and see how it works. Okay, we have a nice exercise. You've done this before in codices, but you could use a very similar logic here in the TIA portal, but it's a very good exercise to make your hand dirty with TIA portal and see how you could use the environment in the TIA portal and interfaces, how you could download it to TIA simulation or TIA sim. Implement the traffic light control in 2 directions in TIA. Use the 6 outputs as the 6 traffic lights in the 2 directions and start the process by closing one of the input switches.